Hi everybody, I am Dr. S. MOHANAVALLI. Welcome to our channel BSc Mathematics Lectures. Before going to the video, press the subscription button and the bell symbol so that you can get notifications about all the videos of our channel. Now, let us go to the video. The topic of this video is solving LPP using graphical method. A LPP which contains only two variables, then the graphical method can be applied to solve that LPP. Now, let us take one problem. Solve the following LPP by using graphical method. Maximize z is equal to 25 times of x1 plus 20 times of x2. Subject to the constraints, 16 times of x1 plus 12 times of x2 less than or equal to 100. And 8 times of x1 plus 16 times of x2 less than or equal to 800. And x1 comma x2 greater than or equal to 0. Now, let us go to the solution. Here, only two variables are involved. Then, graphical method can be applied to this problem, to solve this problem. First, we have to plot these regions in the graph. That's why we consider this inequality as equation. 16 times of x1 plus 12 times of x2 equal to 100. Here we have to find out 2 points from this line, in this line. That's why we put x2 equal to 0, then 16 times of x1 equal to 100, that is x1 is equal to 100 by 16. And put x1 is equal to 0, then 12 times of x2 equal to 100, because as x1 is equal to 0, this becomes 0, then 12 times of x2 equal to 100. That is x2 is equal to 100 by 12. Therefore, the points on this line are 100 by 16 comma 0 and 0 comma 100 by 12. The x1 value should be right as first value. The x2 value should be right as the second value. Here x1 is 100 by 16 and x2 is 0. That's why we are writing the point as 100 by 16 comma 0. Here the x1 value is 0 and x2 value is 100 by 12. That's why we are writing the point as 0 comma 100 by 12. Now consider the second inequality. Consider this as equation 8x1 plus 16x2 equal to 800. That is 8x1 plus 16x2 equal to 800. Here also in the same manner put x2 is equal to 0, then we get 8 times of x1 is equal to 800, that is x1 is equal to 100. Put x1 is equal to 0, then we get 16 times of x2 equal to 800, that is x2 equal to 50. Hence, the points on the second line are 100, 0 and 0, 50. Now, we plot these inequalities in the graph sheet. The given two constraints in the graph sheet. Here, I take the graph sheet and plot this line as x1 and this line as x2. Here, we are having the non-negativity restriction. That's why we are having the two positive axes only, two positive sides only. Now, we plot those points of equation 1 and 2 because we want to plot these two regions. Here, I plot the first line. Now, here I plot the first line. Now, we have to decide either this region or that region. So, we can take any point here and we can check either this region or that region. Now, I take the point origin 0, 0 in the first inequality, that is 16 times of 0 plus 12 times of 0, that is, it becomes 0, 0 less than or equal to 100. Is it true? Yes, of course, 0 less than or equal to 100. Then, this is our region. Now, let us go to the second constraint. 8x1 plus 16x2. I plot the line here. Now, we have to find out either this region or that region. Now, also we have to check with one point. Now, also I take the origin 0, 0. I put 8 times of 0 plus 16 times of 0. Is it? What is the value? Here we get 0. 0 less than or equal to 800. That is true. Then this is the region. Now we have to find out the first quadrant area and which satisfy both the regions. Here we are having these two regions. That's why this is the feasible region. We know one theorem which says the optimal solution exists at the extreme points. Extreme point means the turning points. Here we are having a closed convex region which satisfies both the regions, which contain both the regions. This is the feasible solution. We name it as O, A, B. Already we know A and B. As usual, O is the origin. Now, we plot these 3 points O of 0, 0 and A of 100 by 16, 0 and B of 0, 100 by 12 in the objective function. So, substitute 1 by 1 in the objective function. 25 times of 0 plus 20 times of 0 is 0. For the second point, 25 times of 100 by 16 plus 20 times of 0 is 625 by 4, that is 156.25. And Z3, the third point, 25 times of 0 plus 20 times of 100 by 12 is 500 by 3, that is 166.6. Hence, the optimal solution is x1 is 0, x2 is 100 upon 12 and z is 166.6. This is the optimal solution for the given problem using graphical method. If you like this video, press like and share this video to your friends. If you have any comments and doubts, write it in the comment box. If you like this subject, watch the other videos of our channel. Thank you. Thank you for watching.